Right, welcome back. MECH2320. We are getting into chapter 26. We're going to talk about Y delta starting. So if you remember back in electrical class, right, we talked about Y to delta, delta to Y, all those different things, right? And it was what was really going on there, right? Remember, based on the connections, it was different versions of series parallel combinations. All right, and we did that to be able to control currents in voltages. So, and you're going to see how we have advantages versus Y versus delta and how we connect them up in this chapter. All right, so if you don't remember that, look back at your 1310 class so we can understand. It's in the transformers lectures or things like that, but because I don't really want to go into the details too much here about Y and delta and the wiring and all of that piece. We're going to do some examples, but we really should have learned about that in the electrical class. Okay, so we want to be able to calculate starting current for a motor, whether we're in delta or whether we're in Y, sorry. And then we're going to go over requirements for Y and delta starting and talk about open and closed transition starting again. Okay. So when do we use this? All right, transformers, any kind of transformer starter we're using with higher end voltages and things like that that require a huge inrush amount of current when they turn on. So we want to be able to reduce that and control it. So in our case, when we're going to use a Y delta starting, okay, we are going to limit the inrush current and we're going to reduce the starting torque. Okay, so what we sometimes call it like a soft starting, that's really what happens. So if we look at last lecture, right, we talked about auto transformers and we used, a delta, straight across, and we did some different tappings and things like that to control the inrush current. So this, okay, we're going to switch back and forth between Y and delta, kind of like when we did the lecture where we talked about resistors in series with the line versus reactance in series with the line, and we're able to control the inrush current there. In this case, we're going to control the current using a Y delta transformer. Okay, so let's go over just a couple. We're going to do a few examples here so that you can kind of understand, and you need to understand the difference between like the line voltage, okay, and then the stator line, or I'm sorry, the phase and versus the line. The line's really what's going in on the stator versus the phase. That's what's coming in from the outside. All right, so let's take a look. A couple examples we're going to go through. So we have an assume the motor is to be connected to 480 volt three-phase power line, and we're going to assume the windings, okay, on the stator have a 0.5 impedance. So if we look at the phase voltage here, we're going to take 480 divided by 0.5. That gives us 960 amps. Okay, so right now we're going over being connected in delta. So this is a delta connection right here. When we do this, okay, our delta, okay, line is 3 times greater, or square root of 3 times greater than the phase line. So we have to take our phase current and multiply it by the square root of 3. When we do that, our line current, okay, is 1662 amps. Okay, so that's going to be our line current if we were in delta. So if we did across the line starting and we just used delta right up, okay, normal connection, we would have 1600, a little bit more than 1600 amps going straight into that motor all at once. But if we add and take a look at what a Y is, okay, let's take a look at what the line voltage, or what happens. I can't talk today, guys. I'm sorry. What line voltage happens when we have a Y connection? So when we do this, all right, and some of you guys, if you've been in industry or things, you're like, oh, this is where 277 comes from. Okay, it's by a factor of a square root of 3. So in this case, okay, our phase voltage is going to be less than our line voltage by a factor of a square root of 3. So we're going to take 480 divided by a square root of 3, and that's going to be 277. Okay, so that's going to be our line voltage now. So now if we take 277 and divide it by 0.5, we have 554 amps. All right, so what's the point of all this, right? Well, we want to avoid the inrush current, all right, so that we don't damage the motor. Notice if we're in delta, okay, our inrush current, man, that's over almost 3 times more than if we're in Y. But we don't want to operate in Y because if we're in Y, that may not be enough current to keep the motor where we want it, all right? We might need, 1,000 amps or 1,200 amps to run this motor properly, but we don't want to be in delta at the beginning because there's too much current, and we don't want to run it in Y because there's not enough current and we would damage the motor. So we're going to use the combination here of a delta Y connection to start the motor up. So we can see the difference here in current, all right? If we're in delta, we're going to have higher current. If we're in Y, we're going to have less current. So we can use that, okay? That's what will be coming across the line during the starting period. Because notice when the motor settles down, all right, it's going to not draw that full 1600. We've got to get it started. So that's why there's that inrush of current. All right, so let's do another example here. All right, we have a stator winding of 2300 volts, and the impedance on the stator is 6 ohms. What's going to be the inrush current if we connect in delta? All right, so same steps as before. Okay, we're going to take 2300 and divide it by 6. So that's our phase current. But remember, our phase current, all right, is less than our line current by a factor of a square root of 3. So we got to multiply this by a square root of 3. All right, so our line current, if we are wired in delta, is going to be 663 amps. But if we do it in Y, okay, we have to reduce the voltage, so we're going to take the 2300 divided by square root of 3, we're going to get 1327 for the volts. And then when we take 1327 divided by 6, we're going to get 221 amps roughly. So it's very, very imperative, right? It makes sense. We're going to start it in Y, and we're going to run it in delta, all right, to protect the motor. So that's the whole point of this when we have a Y delta. And remember, go back and look at the Y delta transformations that we did in electrical class, and you can see the different series parallel combinations of the resistance, okay? So let's just briefly go over Y delta starting requirements. All right, the motor's got to be designed for the stator windings to be connected in delta during run, okay? So we're going to go through kind of hookups here in a little bit. And then you have to make sure that you have all the stator winding leads accessible. So that's that little box on the outside of the motor, right? We take that cover off, and you're going to see all the different leads there that we can hardwire to. So that's very, very important for us to be able to get in there and wire it up. Because we can change Y to delta, delta to Y, however we want when we connect it. But it's going to be very, very important. Okay, the power requirements for both are the same. All right. The induction motor, though, we've already done these calculations. Okay, they're based on what? The frequency and the number of poles that are in there. So that's going to be based on, that's how we get the RPM. We did that, like 5 or 6 lectures ago. All right, so that part's not going to change. So the motor still has to operate based on those specs. Okay, so now this is the standard number of leads for a single voltage motor. Okay, a single voltage motor. So if we take a look at this, all right, delta and Y and where the connections go. So if we take a look, you can see how they relate. And it's easier. Sometimes we draw the delta inside the Y, and it really kind of helps us see, where, or we put the Y inside the delta, or the delta inside the Y, however you kind of want to see it, wherever it goes, so that you can make, the connections. All right, so let's talk a little bit about dual voltage motors. All right, so what we just did before, we got a single voltage coming in, but we got a dual voltage connection here. So this is for motors that can operate on different voltages. So it can operate at 240 or it can operate at 480. So we have to have separate windings for each phase as they come in. So notice our delta Y connections get a little bit more complicated. We've got a lot more leads that come in for a dual voltage motor. Okay, so sometimes your motor needs to operate at dual voltage, so that's fine, but it's going to be imperative that we make sure that we really pay attention to those contactors there, okay, and what we're connecting and who connects to what. And that's usually on the inside plate of the motor. It'll show you exactly how to connect it, okay, based on whatever the manufacturer's specs are on it. Okay, so you're going to get a terminal connection diagram when you get your motor, okay, and you're going to be able to see which ones connect to the lines coming in, okay, and which ones terminate at the motor. Okay, so you can see where L1, L2, L3 come in, and then 4 through 9 connect at the motor. Okay, and those connections, it's pre-wired internally for you, all right, to all the correct stator windings. You have to make sure that you make the correct connections here based on what the manufacturer says to do. Okay, so if you notice, like if we look at the delta at the top, right, T4 and T7 are connected. So it's going to show that connection, all right? Those are internal connections, okay? So T4 to T7 is an internal connection. T5 to T8, internal connection. T6 to T9, internal connections, okay? So you don't have to worry about those pieces. They're internally connected, okay? You are going to tap into the external connections, okay, when it tells you to. So you're going to have to tap into T12, but you don't have to make the connection internally on the windings, okay? So just make sure that you understand where the internal connections are, okay? So like I said, you're going to get these, okay, the voltage connecting diagrams. So if you look, it looks different. If we want the higher voltage, so remember we talked about the 240 versus the 480. So the one on the left, it might be how we connected up for 480 voltage, and the one on the right might be for the 240, okay? So take a look at the bottom down here. That's what you're actually going to see. It might be on the outside of the motor, it might be on the inside of the plate, okay? And it's going to be on something that's like clear coated and things like that so that it's protected as well. But it tells you where to wire up. So when you pull your line in, you're pulling in, you know, like 1, 2, and 3. That's your lines that you're pulling in. The other connections are made so that you know if you're using delta or Y, or if you want to pull from 240 or 480 on that particular motor. Okay, so it's important that you understand, you know, all the different aspects of that and how you're going to wire it up. We'll see that on, we have a couple labs where you actually have to follow this and wire things up correctly. So you'll get some hands-on with this. And the only way to really kind of, you know, understand this is once you get hands-on and you can actually open up and take a look at the wiring inside the box there. Okay, so what do we want to do though? We got to make sure that we're connecting the stator leads, you know, properly. When we do this, we want to make sure that we wire in Y. So that's our start. We want to start in Y and we want to reconnect in delta for normal operations. Okay, so we want this to happen here. So if we take a look at the motor, okay, see where all those contactors are, T1, T2, T3, T4, T5, T6. Okay, that was on the diagram before. And so based on that, we know our delta to Y and how we hook those up. So some of that's going to be the delta, some of that's going to be the Y. And that's why it's very important for us to put all the wire numbers or the terminal numbers on all of these. Okay, so notice on the far right hand, those are our start, okay, versus our run. So very important that we understand. And before, when I was talking about, hey, remember we can put the Y inside the delta. That's done for us at the top. You can kind of see how all the connections happen, where the contactors are, so that we make all those. Okay, this isn't something that you just kind of blow through. You need to study it for a little bit and make sure that you understand it. You know, especially when you're in the field wiring something up. Okay, so very, very important here. All right, and then it comes down. Let's look at the controls again. So at the top, we got our power, right? And down below, we have our controls. Once again, to do all of this, okay, we're still using on delay, off delay timers. So we already did that. Okay, we've gone through that control diagram before, so that you understand. In this case, we're not using any off delay, we're using all on delay timers. Okay, you can just tell by the symbol. It's understanding the symbol, being able to see, oh yeah, what's going on. Hopefully by now you can go through this whole diagram at the bottom and understand how everything starts up. Right now, we spent a lot of the first few lectures, going through and understanding the diagram, the control diagram. Right now we're understanding like the power diagram and how that's impacted. We should be able to look on here and see, oh, this is delta. But this is still how we slip between going from Y to delta, right? We start in Y and then we transition to delta. We don't want to lose any power during that transition, so that's why we have to do this in our controls. Just like when we went from using resistors to stop the inrush current and reactance to stop the inrush current, we had to do the transitioning. So we have closed transitioning here. As it happens, we're using the timers to close that transition so that there is no loss of power, voltage, or anything as we go through all that. All right, guys. Hopefully, we got a little bit better sense of why we would use a Y to delta starter, okay, and understanding we're still, starting controlling that inrush of current and the relationship of why we use the Y, right? We produce less current with the Y, where we control the inrush current, all right, so we protect the motor, but then the Y is not strong enough to run the motor. We can switch back over to delta, but delta has too much inrush of current that can damage the motor, so that's why we have to use a delta to Y, okay, starter for this particular type of motor, all right, to protect it and make sure that it operates where it needs to be. All right, guys, if you have any questions, remember to email me or let me know if we got a Zoom meet or team meet or anything along those lines. Else, guys, have a great day. We'll see you in class.